Let's look at the third example problem. So computing average footages. So you're again given information of n houses, and you're asked to calculate the average size, so average footages. You're asked to calculate two of them, one for houses with 3 or fewer bedrooms and one for houses with 4 or more bedrooms. So each house will fall into one of the two classes, and it's guaranteed that there exists at least one house of each kind. So this should be pretty straightforward. So given this sample input with 3 houses, the first two have 3 or fewer bedrooms, one have 1,000 square feet, the other have 2,000, so the average is 1,500. And there's only one house with the 4 or more bedrooms, so the average is just 3,000. So this question asks to compute the average. So how do we do that? Again, it's fairly straightforward. So we first compute the sum, and at the same time we also compute how many houses there are, and then we just divide the sum by the number of houses. So to compute the sum, we'll initialize this sum variable to be 0, and then each time we see a new value, we just add to the sum. So this is the code for doing it. So we have two sum variables. So sum1 is intended for the total price of houses with 3 or fewer bedrooms, and sum2 for 4 or more. So normally we will keep track of number of houses of the both kind. We should have n1 and n2 as well. But since each house will fall either into one kind or the other, and we know the total number of houses, so we only need to keep track of one of them. Everything else is, we've seen this several times. So here we should specify the condition that the number of rooms is less than or equal to 3. I just try to show that you can express the same condition in many different ways and sort of illustrate this not. So that condition can be equivalently specified by saying it is not the case that the number of rooms is greater than or equal to 4. So of course, if I wouldn't use this when I'm actually writing this program, because I'm trying to express something simple in a way that's more convoluted. This is just for illustration purpose. So we compute sum by just add that footage to sum1. So for sum2, I use this introduce a new operator, so plus equal, and what it does, essentially, this is equivalent to sum2 equals sum2 plus footage. So because this adding a value to a variable is so common, so C introduced this syntax of plus equal, and C++ inherited that, and Java also did that. And there's another syntax introduced in C for sort of convenience, this plus plus. So what this means is we'll add 1 to this variable. So this is equivalent to roughly equivalent to n1 equals n1 plus 1. So after we compute the sum and n1, and then we can print it out. So here I showed that in the past, we always have a variable store the value, and then when we we just use the variable here when we do this sending it to cout. But essentially, what can go in here is the expression. So a variable is the expression, but we can also use a more complicated expression. We can basically put this expression to calculate the average directly here. So sum1 divided by n1, separate by a white space, and then this is sum2 divided by n minus n1. So the concept that we introduced in the solution code for this problem include the logical operator not, where this is the first time we see it actually used, and then we have a plus plus and plus equal. So plus equal A plus equal B means A equals A plus B. So plus plus can be used either before or after a variable. So there's I believe in the comment in the code I explained the difference. But actually for now you don't really you shouldn't be writing code where they make a difference. So the code you write wouldn't the difference wouldn't really really matter. Well, okay. So the difference essentially, this is an expression. It will change a in both cases by adding 1 to a. But what this expression evaluates to, there's a difference. So a++ evaluates to the value of a before adding 1, and ++ a equals to the value of after adding 1 to a. But oftentimes when we write just a++, we're not really using this value anymore. So we just add 1 to a. We're not further using this value in some other computation. We're not doing, say, b minus a++. Then it doesn't really matter whether we are doing a++ or ++ a.